Hi, this is Michael Cantu,
And this is Peter.
and we're working on our Yelp presentation. Thank you for listening. We're doing analyzing Yelp data to understand the patterns of success. Okay, for motivation, we want to see if there was a way to measure the success of a restaurant within the Yelp dataset. We thought this would be an interesting aspect to explore, as because if we were able to successfully figure out the successful patterns, it would be very beneficial for all restaurants, especially ones with poor ratings.
So, in our analysis and modeling, the main data set we focused on was the business JSON data set. And this data set consists of location data, attributes, and categories for the businesses listed on Yelp. So, one of the main issues we came up when we were cleaning this business JSON data was issues in regards to the business location data. So in the city and state columns of the business data, there were issues such as spelling errors, typos, formatting issues, or just as well missing data. So one technique that we could have used to rectify this issue was removing any observations, any rows with this data issue. But one downside of removing data with faulty values is that you could potentially be losing data that could be valuable later on in the analysis and modeling. So one technique that we use to mitigate this issues with the location data was we use the longitude and latitude values included in for each business in the business JSON file, and we fed those longitude and latitude data values into external geocoding APIs to find the true city, state, and location data for each business. Other problems that we encountered in the dataset not related to location data was generally missing data's NAN values. So to mitigate that issue, we assigned default values to replace those missing values. So for numerical data, we assign the lowest value, such as 1 to the missing data, or for logical data, we assign values of false to missing data.
So for the EDA analysis, how we deemed a successful restaurant was that if it had a majority of 5 stars and had the highest number of reviews. Doing this, we noticed that there was a pattern that in Nevada and Arizona, they had the top 15 restaurants in all the states that we were looking at. The only similarities within the categories of all 15 restaurants was that 2 of them were breakfast restaurants.
So from the main data set that we are focusing on, the business JSON data set, and the scope of the question we were trying to answer, we had to focus on 2 subsets within our original data set. One subset consisting of only European restaurants, and the other subset consisting only of Asian restaurants. So to get these 2 subsets from the original dataset, what we did was we processed and filtered the original dataset based on the categories attribute of the dataset. So the categories attribute of the dataset contain values such string values such as Asian, European values for restaurant businesses listed in the dataset. But another caveat that we had to account for was that there were also restaurants that had both Asian and European restaurants in the categories attribute. So that meant that those restaurants served both Asian and European cuisine. And those restaurants may have been restaurants such as buffets, but our analysis did not want to focus on them. So we removed those from our resulting data sets. Another issue that we had to account for was that some restaurants did not list themselves as Asian or European or any other type of ethnic cuisine in the categories. So our data set might have missed out on, so our resulting modeling analysis may have missed out on those Asian and European restaurants because we weren't able to find them within the data set. Another issue that we had to account for was some restaurants may have only listed themselves as Chinese or French or Italian and may not have included the meta value Asian or European in their categories attributes. So we had to account for that too in our data processing.
For the attributes extraction and features, what we did was look at the top 15 restaurants from earlier and looked at the attributes. We were able to successfully extract the attributes from the nested dictionary that the original Yelp dataset had provided, and see if 7 or more of the top 15 restaurants had any of these specific attributes, and if so, we would further clean those attributes and use them as our features. The most beneficial attribute was business parking, which had to be further extracted as that was in a nested dictionary in itself, containing if restaurants had valet, validated parking, a parking lot, or a garage.
So here we present the performance results of the models we fitted to the data. So for the question we're trying to answer, our main focus is on binary classifiers. So models we use included logistic regression as well as ensemble tree methods, gradient boosting classifiers. And we could have used more advanced techniques such as neural networks, but our goal for the project was to basically stick with simple models that were able to be explained fairly well, which is not something that we could have easily done with black box deep learning models. So for most of the scope of our project, we were basically predicting using binary classifiers, predicting whether a restaurant will be successful or not. But later on, what we also did was we did multi-class classification on predicting the actual star ratings for the restaurants. So as you can see, we present the results for the ROC scores for the logistic regression as well as the gradient boosting classifiers. And basically, a ROC score of 0.5% means that the model is pretty deficient. It's not something you really want. While a ROC score of 1 means that your model is perfect and you'll be really happy with that model. So you can see for the models for the binary classifiers, most of our model ROC scores are around the 0.7 area for both the logistic regression and gradient boosting classifiers, which is not perfect, but it's moderately well, and it's something that we're pretty happy about. For multi-class classification, it's a little harder because instead of having a binary target label, you have multiple class labels. So for star ratings, you have stars ranging from like 1 to 5, and we rounded down 0.5 star ratings just to get the number of total classes down to a smaller level. And basically, as you can see, for one of the multi-class classification models that we did on Asian restaurants, the test classification accuracy, which is basically 1 minus the error rate for the multi-class classification model performance on the test set, the accuracy rate was 0.51, which is barely better than a coin flip. So basically, our binary classifiers had much better performance than the multi-class classification models that we later did. So future steps that we could do to improve and extend our project's analysis and model include exploring other ethnic cuisine categories. In our project, we basically looked at European and Asian restaurants, but there are definitely a lot of other restaurants out there, including Mexican and Latino restaurants, for example. What we could have also done was we could have augmented the Yelp data set with other external data sets, such as census data. Perhaps there is a relationship between the ethnic demographics of an area, of a county or a state or a city, and how well certain ethnic restaurants do. As I mentioned before, we focused on logistic regression and gradient boosting classifiers, but there are definitely other types of models out there, such as neural networks or random forests that we could try to use for classifying. And other features that we could have possibly used to improve the model performance include features such as a restaurant's physical location, physical distance to other restaurants. We could assume that generally, like if restaurants are close to other restaurants, that there's a bit of competition going around, and that may affect how successful a restaurant is, how much ratings and reviews it gets. Other features more specific to the Yelp ecosystem that we could explore includes whether a business having photo and check-in data on this Yelp listing had any relation to its success or the ratings reviews it has. For example, like there might be a positive correlation to a business having more photos of food and its menu to how many reviews, check-ins, and ratings it gets.